All right, exponentials. You don't need to know any of that crap. 3 to the x, just the basic exponential. 1. 10 to the x, basic exponential. Oh, sorry. Number 2. 3 to the negative x. Your x is changing, so you're just rotating about the y-axis. 10 to the x. Well, it gets faster, but I mean, essentially you can't really draw that. But there it is. There's 1 still. 4. 1 on 6 to the x. As you can see, you're going to still draw it at 1, right? So the problem is, the question that comes up is, how do you know the difference between this, this, and this? They all look the same. So what you are going to do for your examiners is just put a point or plug in a point or two to tell them that you've actually drawn the right one, and you haven't drawn 10 to the x here and then drawn 3 to the x down here. So all you would do is sub in x is 1, 3 to the 1 is 3, and you would say that's 3. And this is 1 for question 3, 10 to the 1 is 10, so you would write that's 10. The other one is 1 on 6 to the x, so again when it's 1, this is going to be, oh, what happened this way? 1 on 6, oh crap, I drew this wrong fraction. And you can obviously see by subbing in a point, 1 on 6 doesn't make sense when that cuts at 1, right? So I'll quickly draw up why that one goes the other way around. That's that one. At 1, it's 1 on 6, and here's the reason. 1 on 6 to the x, which equals to 6 to the power of negative x. Right, so that's actually the same as question 2. Question 5, I mean, sub in x equals 0. When you sub in x equals 0 for question 5, you get y equals 2 to the power of negative 1. So when x equals 0, y equals 2 to the power of negative 1. So when x is 0, y is a half. 2 to the power of negative 1 is a half. When x equals 1, 1 take away 1. When x equals 1, 1 take away 1 is 0. 2 to the power of 0 is 1. So at 1, it's 1. Now I feel like we know the answer to this, right? You got 1 point, you got another point. You know it's an exponential. It hasn't been shifted up or down. And voila. If you want to see this broken up just a little bit differently, use your index laws. 2 to the x times 2 to the power of negative 1. So that's just 2 to the x divided by 2. That's all you're drawing. See, instead of it cutting at 1, you're cutting at a half, and that's why. Question 6, however, it's saying 2 to the x take away 1. So now you're actually shifting your whole exponential down 1. So instead of your asymptote being at 0, your new asymptote is at negative 1. Right? Do we get that? Because usually it's at 0. Now you're going to shift it down. It's at 1. If you want to see where it cuts through, I mean, sub in 2 to the power of 0. 2 to the power of 0 is 1. 1 take away 1 is 0. It cuts at 0. But again, you guys should know that because originally it cuts at 1. But now you're going to subtract 1, so it cuts at 0. And there it is. Please let me know if I've confused anybody, if I'm going too fast. Question 7. Y equals 1 take away 2 to the power of negative x. Well, there's a lot of things that have happened here. I would first draw 2 to the power of negative x. So 2 to the power of negative x is like this. Right? That's 2 to the power of negative x. Negative 2 to the power of negative x, well, negative just means flip it down. Plus 1 is the one is shifting this one here up 1. So your asymptote's now going to be at 1 instead of it being at 0. Instead of it cutting at negative 1, it's going to cut at 0. And that's the answer to that one. See how I did it slowly? I first drew the basic form, 2 to the negative x, then I get a negative, so you just flip it down, and then plus 1, you just shift the whole thing up 1. All right. Any questions?
Wait, Sam, can you go through that last one again? Sorry.
You want to do a different example, or you want to do that exact one?
Can we try a different one?
Mm-hmm. So try to see if you guys can draw this one. 3 minus 2 to the power of negative x. What would happen in this case? Again, 2 to the negative x. 2 to the negative x is this way. Do you agree with that, Aya? That's this way?
Yeah.
2 to the x is this way, right? So 2 to the x is this way. That means 2 negative x is this way.
Yeah.
But it's saying negative in front of it as well, which means you got to flip it down. So it's actually this way.
Yeah.
So that is negative 2 negative x, and your asymptote's at 0.
Mm-hmm.
But now you're shifting up 3.
Oh, yeah, that makes sense.
So instead of it being at minus 1, you're going to cut at negative 2. Instead of it being at 0, so minus 2. Instead of it being at 0, your asymptote's going to be at
3.
Because everything just gets shifted up 3.
Yeah.
And then draw it from there to there. Make sense?
Yeah.
All right, extension 1. When you see X1 in these booklets, that means these are extension 1 questions, not advanced. So harder graphs, so this could be something that's tested in your extension 1 topics. The reason why it's in extension 1 is because you guys are the ones that learned transformations of like absolute values, reciprocal functions, square roots, blah, blah, blah. So the way to do this is you follow the same rule that I would have said when we did something like this. Right? We would have learned this. I said draw this up. Ugh. And then what does absolute value of x do compared to the whole absolute value? Anyone know what absolute value of x would do?
Copies the positive x values to the other side.
You've memorized exactly what I would have said. Copy all the x's, the positive x's, to the left-hand side. So your answer is this. So if I've got y equals 2 to the x, right? You would have drawn this. If I said absolute value of x, you do exactly what Greg just said, which is copy all the positive x's to the other side. There it is. Easy, right? If you follow these rules that I made you guys copy down and stuff. Or personally, I memorize what each transformation does to this basic graph that I made you draw. So I've memorized all these. And then eventually you can apply it to absolutely any graph you have. Any questions about that? All right. What about this one? Sketch y equals 2 to the x. Is this still part of extension 1? Yeah. So only extension 1 students because of the fact that you're adding your ordinates, right? So maybe handy and stuff. For you guys, this might be a little bit more fresh because you guys just had your test on this. All you're doing to do this, you're going to draw 2 to the x. There it is. You draw 2 to the negative x. There it is. And then what are you going to do now? You'll be adding your ordinate. So you're adding this plus this. So the easiest one to start with is here. What's 1 plus 1? 2. But what's this number plus this number? It's always going to be twice as big. What's this number plus this number? Well, what's going to happen? Let me just make sure. It's going to be a bit bigger, isn't it? Now I'm just making sure. Yeah. So what's this number? Like what's 10 plus a smaller number like 0.5? It will be a little bit bigger than 10. Right? What's I don't know, this number, like 1.5 if you want, plus 0.7. Well, it'll be a little bit higher than 1.5. Right, 1.5 plus 0.7, but it'll give you about, it might come down a little bit. What do I think? What do I think is the answer to this question? I think it's going to be pretty flat at x equals 1. All right, let's make sure I can give you guys a good answer. So if you want to make sure to get it very, very accurate, you can sub in numbers at all times. So I subbed in 0, 2 to the power of 0 plus 2 to the power of negative 0. It will give you 2 because that's 1 plus 1. Let's sub in 1. So when x equals, well, we'll just do a table value. It'll be easy. So don't be afraid of that. If you ever get stuck, you're not sure what to do, just draw a table value 3, 4, 5. That's good enough. All right. Negative 3, negative 2, negative 1, 0, 1, 2, and 3. Sub in x is negative 3 into here. What do you get? You get 2 to the power of negative 3 plus 2 to the power of positive 3, which is 8.125. We're just going to go 8, roughly 8. Now if you sub in 2, you would get 4.25, again, roughly 4. Sub in 1, you get 2.5. You sub in 0, we said you get 2. Sub in 1, what should happen, because it's symmetrical, you should get the same answer. So what you should get is 2.5 again. If I sub in 2, again, because it's symmetrical, you're roughly going to get 4. Sub in 3, you're roughly going to get 8. So I think from there you can safely conclude the answer. Any questions? No? That makes sense. Yes. Or like I said, you could just add this plus this will be a little bit higher. This plus this a little bit higher. This plus this a little bit higher. And so on and so on. Okay. Logs. Log graphs. So log graphs look like this. I'll make a point about from a different topic as well. They are inverses of each other, because I know I was asking me this week, so I'll make it clear for everybody again. They're inverses of each other. So for example, an exponential is like this. What's the domain of an exponential? All real x. What's the range of my exponential? Y is greater than 0. Because they're inverses of each other, your logs look like this. when x equals 0, y equals to 1 as well, right? You know that, that's at 1. This is an inverse, so that means everything flips. So your domain here will be all, the domain here will be x is greater than 0, right? Flipped. Your range is all real y, and when y is equal to 0, x equals to 1. So when x equals to 1, y is equal to 0. Exactly like that. All real y, which we can see, and x must be greater than 0. You can't log a 0 and you can't log negatives. So log graphs look like this. Okay. All right. Any questions? And the inverses, the idea is your domain and range can change as well. Does that make sense now? How the range becomes a domain here, and the domain becomes the range here. And same thing with the points. Like when x is 0, now it's when y is 0. When y is 1, now it becomes x is 1.
Yeah.
Only everything except for your inverses. The inverses, for your inverse trigs. Inverse trig, now your domain and range is according to your inverse trig. So you don't get your original sign and then you try to find the domain of that and range of that. You don't do it that way. Okay. All right. Transformations. I mean, doesn't really do anything, but let's try it out. Log of 2x subbase 10. Log of 2x subbase 10. Well, that's the same. That's pretty much, if you guys remember what we did last week, that's the same as saying log 2 plus log x. Log 2 plus log x. So your log x curve is that. Plus 2 is just shift this thing up 2. Well, even if you shift it up 2, it'll still look like that. It's just that the intercept will change. And we can work all of this out, right? We can actually work out when y is 0, we can work out its intercept. So the answer is that. If you want to know what this is, you can always solve it. So when y is equal to 0, you want to find the x value. It looks like this. 0 equals log 2x on log 10 times by your log 10. That's still 0. How do I get rid of the log? You exponential both sides. This cancels out. E to the 0 is 1. So x equals to a half. And that's it. Otherwise, that hasn't moved anywhere, hasn't really, I mean, it's shifted up to, but you can't really tell the shift because you're not moving the left and right. So the asymptote's not changing or anything. Question 2, it says log x squared when x is greater than 0. So what are you going to do with that? Well, what are you going to do with the 2? From our log laws, the 2 comes down, right? So you're allowed to bring your power down. That becomes 2 log x on log 5. Again, log x, if you want to solve it, why not? I'll let you guys get used to this solving. 0 equals 2 ln x on log 5, times it by 0, gone, divide by 2, gone. So you just get 0 equals log x, exponential everything, you get 1 equals x. So in fact, this one hasn't changed. The intercept's still 1. But obviously, 2 on log 5, it makes it a little bit, 2 on log 5. Plug it into your calculator. And if it gives me an answer, 1.24. It just makes it a little bit sharper, but like, whoops. But I mean, the difference between drawing that and that, sharp or thinner, you're not going to be able to lose or gain marks for that. I'm more interested in these intercepts and probably another point. Maybe if you want to sub in x equals 2 into here. So like log 4 on log 5. So that becomes log 4 on log 5. I subbed in x equals 2. 2 squared. Change the base. Let's try number 3. Log 3x take away 6 on 6. So log 3x take away 6 on log 6. Again, on log 6. Again, if you wanted to solve for x, by all means, just make y equal to 0. Times it by log 6, it's gone. Exponential both sides, you get 1 equals 3x take away 6 plus the 6 is 7. X equals to 7 over 3. So this number here is 7 over 3. And then just draw your log. Has not shifted up or down because it's attached to the x. No, that was wrong. That one has because it is attached to the x. We're not moving up and down. So 3x take away 6. So this one here, you've got to also solve the inside for it to equal to 0 because you can't log 0. Right? So you'll go 3x take away 6 equals 0. 3x equals 6, which means x equals 2 is an asymptote. So you can't get 3 times 2, which is 6, 6 take away 6. You can't log 0. So at 2, it's an asymptote. And then you're drawing this. So the asymptote's not at 0, like these other two were. That has shifted. And the reason why it shifted is because attached to the x. Attached to the x would move left and right. So like same as this one, it's moving left and right, so it's attached to the x. So you first go 2x plus 3 equals 0, 2x equals negative 3, x equals negative 3 over 2. So now you know your asymptote is at negative 3 over 2. And then I mean you can just solve if you want to work out your intercept. 0 equals log 2x plus 3 exponential. You get 1 equals 2x plus 3. 1 take away 3 is negative 2. X equals negative 1. So there it is, negative 1. And then you even have, in this case, you even have a y-intercept. When x is 0, you get log 3, 7. So that's a log 3 sub base 7. So all I'm doing is just trying to work out where the asymptotes are and where my intercepts are. And then from that, I pretty much know the shapes. Yeah. Log x, well, log x is just this. But because it's absolute valued, then exactly what Greg said before, all the positive x's get reflected to the left. So there it is. That's log absolute value of x. And then of course, number 6 just says log negative x. Well, that will just be the left-hand side. I know that looks a bit confusing at first. When you probably review this, I'll review probably tomorrow or Saturday real quick, just review this section. And you'll just be like, oh, that's simple. All he's doing is just finding x and y intercepts and watching out for asymptotes, because logs have asymptotes that you've got to watch out for with your x's. With your exponentials, because they were shifting up and down, they were easier to identify. So here, when you're shifting 1, they're easy to identify. You're just moving the whole thing up and down 1. Whereas this one, they're a little bit harder because you're going left and right. So you gotta remember, if it's attached to the x, you have to move your asymptotes as well. And the best way to do that is just to solve that equal to 0. It's not allowed. You can't log a 0. Harder graphs. Well, we just did this one, so that was already up there. But this one here, log root x. Again, go back to your originals. So your original questions were here. That was y equals f of x. Y equals root f of x. Y equals root f of x. What we did, we ignored the bottom, and then the top pretty much square rooted, which when you do the square root that, it'll change its concavity because it becomes flatter a bit. And then if it was a squared, instead of root, it was plus and minus, then you would have to draw the bottom as well. So let's see if we can draw this. So first thing you do is, sorry, that's root x, not root f of x. Root x, is that even in the syllabus though? I don't think so, but it doesn't matter. I'll explain that one. So sorry, that was root f of x. So that's rooting the whole y values, whereas this is just root x. It's not this. The way I was attempting it was this. That's root f of x. This one's saying it's just root x. So pretty much you're drawing something like this, which is not a problem. It comes from the family of this. So it's the same concept, because both of these are positive. The only difference is this is a straight reflection, whereas this you're square rooting, so your numbers get smaller. So y equals log 5 root x. Well, your normal one looks like this, right? 1. This is y equals log 5, and then you can plug in any point. You can pick 2, and then you can just write this is log whatever, log 2 subbase 5. It's not hard to show. Root x is just all of these numbers become a little bit smaller. So the good thing is it doesn't change because x is all positive anyways. Root 1 is still 1. But the idea is when I'm subbing in 2, it's no longer at log 2, 5. It's at log root 2, 5. It wasn't hard to draw that, right? The asymptote doesn't change. So for an extension 1 question, it's pretty easy. Log x, well, that's exactly what we just did before. There's your 1. If you want to sub in 2, sub in 2 into here to this side, that gives you log 2 subbase 3. But because it's absolute value, all your positives reflect to the left. Negative 1. And then we'll also say at negative 2, absolute value of negative 2 is still positive 2, so we'll still have the same y value as this. Am I going too fast? Absolute value of y, again, think of your basic one. If I had to absolute value y, absolute value of y, let me recall absolute value of y.
Would that be, if it's absolute value of y, is it all positive y value?
Yeah, reflect down. Perfect. You are correct. So log of negative x. Now, you can't log a negative. Sorry, yeah, you can't log a negative, right? Do we agree with that firstly? So what must x be? If you can't log a negative, what must x be? Just x.
Greater than 0?
Say that again?
Greater than 0?
Oh, no, it can't be. If x is greater than 0, then that's going to be negative.
X itself has to be a negative.
Yeah, x itself has to be a negative. Do you get that? So x itself, x has to be less than 0. So then when that becomes a negative of a negative, it still works. It's still positive again. Yep. So your asymptote's this way, log of negative x is this way. But we kind of know that from a different way from our absolute values, right? I just said absolute value of x, a positive x, and that's your negative x. But I thought I'll just explain it one more time. X is less than 0, so it's going to be this way. And then exactly what you just said before, to draw the absolute value. There it is. Obviously a lot smoother, more like that. Oh, no, it's actually not smooth, because it is absolute value, it won't be smooth. It probably will be sharp. So it'll look more like this. More than curvy. Cool. Y squared. Well, y squared was the one that we were doing just before. Negative x looks like this again. Asymptotes here. Y squared is the same as saying this, just so we remember that. Plus minus. Square root. Square roots, like I said, all positives get square rooted, and then technically they'll become more parabolic in nature. So just think about all the square root of these numbers. They're going to become smaller, right? So pretty much what happens is that, because it's squared, it's that. It's more parabolic in nature. So I think of a number here. Imagine this number here was 100 for this curve. But now you're going to square root 100. Well, square root 100 would bring it all the way down here to 10. And that's why it becomes a lot flatter, more parabolic. Okay. Now we're up to the applications. Okay. I'm happy with that. Let's see. Okay. Still different shape. All right. Let's do this application and then we'll get up to the exponential functions, next bit of it. So a few application questions. These are easy. Sketch log EX I 2000 2-unit HSC question 9 with slight modification. But question 9 is the second last question of the exam, so meant to be hard, let's say. All right, y equals ln x looks like this. There you go. You got yourself 2 marks. Nah, come on. If it wants 2 marks, they want you to show a bit more stuff. So there's your 1. Maybe show 2. So that becomes ln 2. I don't know. And I think that's about it now. For 2 marks, you got your graph. You've shown a point. you want to show another point, you can do that. Double I. On the same sketch, find graphically the number of solutions of the equation ln x minus x equals negative 2. In other words, we would have to rearrange this to make it, so when it's saying number of solutions, just how many times will they touch? And if you can work out how many times they touch, it usually tells you how many solutions you have. So if I've got ln x equals to x take away 2, right, I just plus that over. In other words, you're going to sketch y equals x minus 2. When x is 0, y equals to negative 2. When y is 0, x equals to positive 2. When y is 0, x equals positive 2. How many solutions? Find the number of solutions of the equation. Does anyone not understand that? One solution, right there.
By solution, do you mean how many times it crosses?
Well, yeah, of course. Isn't that what you've been technically doing? Because a solution means how many times they cut or touch. The reason why you know that that works is because when they do touch and intersect, you have to solve this equation with this equation simultaneously, which means you're pretty much going to write this. And when you're solving simultaneously, you're working out their point of intersections. In other words, you're solving for x. So yeah, pretty much. They're all linked to the same thing. When you're solving, you are finding point of intersections, you're finding when they're touching. It's all the same words, just used differently. Easy, easy 3 marks. All right, another HSC question. Maybe I might just move on and try this one instead. Let's try this one. 10 kilos of sugar is placed in a container of water and begins to dissolve. After T hours, the amount A of undissolved sugar is given by this formula. Calculate K, given that A is 3.2 and T is 4. 100% will be in your exam. I haven't said that about anything else. This 100% will be in your HSC and will be in your prelims. Calculate K. So you sub in 3.2, 10, E, negative, K, T is 4. Divide by 10. Anyone know what I would do now? I'm trying to solve for K. I don't like this.
Just log both sides.
You would log both sides. That's the opposite of exponentials, is the logging. And then, obviously, oh wait, do you guys know how I got this negative 4K, or do you guys want me to, maybe I should just, we did that last week. So from last week, we learned if we got log of something, so log of E negative 4K, you can bring the power down. And then log of E is just 1, it cancels out. And that's why eventually you'll just memorize when you're going to log E like this, you just bring the power down. And then divide by negative 4. Plug it into your calculator. 3.2 over 10 divided by negative 4. 0.k equals 0.2849. Try to write them to 4 decimal places, your k's, if you're going to use that answer. The reason why I say that is because usually double I is written to 2 decimal places. If you've written something to 4 decimal places and you substitute that in, then very unlikely you're going to get your double I wrong. Otherwise, never use a rounded answer. Always use a unrounded answer. If you can learn to do that and store it on your calculator. After you find K, K's a constant all the time. After how many hours does 1 kilogram of sugar remain undissolved? A kilogram of undissolved sugar. So when is A equal to 1? You just do it all again, but this time you've got K. Two, 849 T. Divide by 10. Log both sides. Divide by negative 0.2849. So divide by K. Oh, we'll just get the answer out. I think we all know to divide. Have I lost anybody? T becomes 8.08. After how many hours does 1 kilogram remain undissolved? After 8.08 hours. All right. Any questions? Still copying? Or, question 10. That means last question of the HSC. You're talking about state ranking. So we'll look into that in a second. I just want to see if there's anything else. Yep, we'll do that. Why not? We'll do that as well. So 3. I think that's plenty. And you guys will do those last few for homework. So 1, 2. We can do this one. This one looks easy. 2010, 2-unit HSC. Let f of x equal to 1 plus x. Show this. All right. F of x times f of negative x is f of x plus f of negative x. All right, Stefan. Left-hand side. What would you say? F of x times f of negative x. What's f of x?
F of x is 1 plus e to the power of x.
Times f of negative x. 1 plus?
E to the power of negative x.
Expand. 1 times 1 is 1. 1 times this is this. This times this is this. And then what's e to the x times e to the negative x? What do you do when you multiply bases that are the same?
Sorry, what? You cut out.
So what is e to the x times e to the negative x? What do you do when you multiply? Say again?
Plus the tops.
Yeah, good. Plus the tops. X plus minus x is 0. E to the 0 is? What's any number to the power of 0?
Oh, 1, sorry.
Be careful with that bit. So you've got this so far.
Yeah.
Right hand side. What does right hand side equal to? F of x.
1 plus e to the power of x
Plus
plus 1 plus e to the power of negative x.
1 plus 1?
2.
Equals left hand side. You're done. Any questions?
No.
I don't want you guys to look at this and go, oh, Sam's never taught us f of x times f of negative x equals f. I don't know how to show that. Stop thinking like that and stop talking like that. Just do the base stuff. It'll work out. It's easy. Don't worry. First thing that comes to your mind would probably be right. Okay, let's look at this one. Oh, question 10 as well. Not yet. Let's do this question 10 first. A population n of t varies with time according to the law n of t equals CEKT. That n of t is just like saying f of x is equal to CEKX, right? Just so you guys know. Don't even let that worry you. where C and K are positive constants and time is greater than 0, of course. Show that if A and B are two positive numbers such that A plus B is equal to 1, then n of AT plus BU is equal to n of T to the power of A, n of U to the power of B. What the heck is that talking about? So who wants to give it a shot? Come on, there's got to be someone that's willing to try it. N of AT plus BU. Am I going to pick? All right, let's try. Let's try with Azra. N of AT plus BU. What are you going to say to do first?
Would you sub that in?
Into where?
Into T.
Into T right here, yeah, so that I would do that. CEK bracket AT plus BU. Okay, next line. What would you write?
Would you expand the
So
brackets at the top?
CEKAT plus KBU. Next line. What would you write?
Would you separate that?
Yes, 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 yes. Killed it. Times E KBU. Do you agree with that?
Yeah.
Okay, and then now what?
Would you take the A out of the first one? So it's CE
Good
to
job.
the K.
See what she's doing. I mean, she's got the same amount of experience as you guys, but what she's doing, she's now learned to look at this side and try to really force it. And you can see you've got to take an A out. So you've got to force the A out. There it is. Take it out. A. Take out the B.
Can't see
There it
screen.
is. What was that?
Oh, never mind.
Oh, okay. So B. And the reason why that happens, or the reason why you would like to do that, is because all you had here, it says N of U. U just means CE U, sorry, CE UK. There it is. EUK. And NT is just EKT. To the power of A to the power of B. So she's pretty much got that bit done. The only bit that I'm looking at is why do we have just one C? Here would have been C times C. C to the A times C to the B. Ah, sneaky annoying things. All right, again, because you're proving and because it's, question 10, you know, state ranking, blah, 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 you get the idea. They just make a little bit, just that extra bit harder. So like I said, there's a C here. They're both meant to have C's. But then I've only got the one C. But that's why they gave you this. So what happens is this is technically C to the A, and this bit here is C to the B. But what's C to the A times C to the B? Isn't that C to the power of A plus B? And that just equals to 1, which is C to the 1 there. So again, it's just about forcing it. And there it is, and then that just becomes boom. Well done, Azra. I really like the fact that you pretty much said separate here and then take out the A. Have you done this exact question, or have you done a question like this before? Just out of curiosity? Yeah, no, good thinking. Very, very good thinking.
How do you know to separate that?
Look. Honestly, with a lot of experience, that's the truth. Azra has pretty much completed the year 11 course, so it's a little bit easier for her to identify. But I mean, I can't just bring it on that, because I've got year 12 students that won't be able to do what she just did. The only way you'll be able to do that is by looking at exam questions. And as you're looking at exam questions, every time you're looking at this right-hand side that says show, you're trying to force what you've got here, so what you had in this line, to make it look like this line. And the fact that it's got a power of A, you're just going to be like, oh, get this A out. Just have the A out of here. Oh, there it is. And then now that EKT looks like this EKT. EKU, well, with a U, yeah, that would be EKU. And then that extra step here is a little bit tricky, that a lot of students probably don't see. C to the A times C to the B is the fact that that's C to the power of A plus B, which is 1. So that is the same as this. But honestly, I have just a lot of exam questions. Like, why do you think we're doing this right now? You know, I'm not hesitating. You guys got to start learning no more textbook questions. You jump straight onto your HSC questions. Start doing exams. There's nothing holding you back but yourself to doing these. So there you go. And Azra admitted it. She's never seen it before. You don't want to walk into your exams knowing that if this came up in your exams, damn, all you had to do was just do a HSC question and you would have already seen it and learned how to do it. And then you could have gone into your exam and it would have been really easy. To make a point, these questions here, once you get to question 10s, 1 mark is not the same as your 1 mark in, like, obviously question 4 or 5. 1 mark is going to be really long. Sometimes 1 mark takes a half a page. All right, because they just want to differentiate someone getting 99 to someone getting 100. Okay, hence or otherwise, find n of 13 given that n of 3 is 10 and n of 8 and n of 18 is 100. Find n of 13 given that n of 3 is 10 and n of 18 is 100. Okay. Sounds complicated, but that's just exactly what we did before. I just don't have enough room here, so what I've got to do is take it over. No, we'll just do this whole question. So I'm going to send it to you guys. Okay. So double I. Hence or otherwise, find n of 13. Which means obviously t is 13, given that n of 3 is 10 and n of 18 is 100. You know that n of t is equal to c e k t. Let's see how they want you to bring it in. 18. How are you guys trying to link this? Let me see if I can link this for you guys before doing it a different way. N of 13. N of 13. 13. N of 3. So that's 3. T is 3. A is going to be B. U is 10. Oh, I can't see how to bring this in just yet. All right, Mariette, let's do this. N of t equals C E K T. We want to find n of 13 eventually. All right, you know that n of 3 is equal to 10. So what are you going to write? Any ideas? Well, you know n of 3 is equal to 10. So what does that mean to you? What does t equal to?
T equals 3.
Yep, t equals 3. So you get times 3, which is 3k. But what does n of 3 actually equal to?
10.
10. So you get this. Yep, you're okay with that?
Yeah.
And then what are you going to do with n18 equals 100?
You sub it in the same way you subbed in 3.
Same way, so 100 equals CE, T is 18 this time, so 18k. And then you've got one equation and you've got two equations.
You solve
You've got to
it
solve simultaneously. Yes, yes, but how? You've got C there and K there. What's your ID? It's definitely not, I wouldn't say it's elimination. What are you going to do?
We substitution.
Yep, and what letter would you make the subject, C or K?
C.
Yes, correct. And which one do you want? The first one or second one? It doesn't matter now.
It's the first one then.
First one. So C equals 10 on E 3K.
Yeah.
Sub 3 into 2. So it would look like this. 100 equals C, which is 10 on E 3K dot E 18K. And then what's E 18K on E 3K? E to the power of
21.
18K take away 3K.
21. Take away 15k.
Yeah, and then divide by
10.
that gives you this, and then what do you do to both sides?
Sub.
And then you divide by 15. You just found your K, which is the thing you need to do N13. So to find N13, which equals to C E K T. C E K, which we have, T, which we have, just 13, C we don't have. But how do I find C? In here.
From, yeah.
From 3.
Equation 3.
And then that's it really, isn't it? So
Yeah.
C you have, because you already know what K is, you sub it in here. All right. So let's all try to see if we can get an answer out. All right, I'm going to sub in K into here to get C out. So 10, log 10 on 15 is that. So I'm going to store that. I'm storing my K as letter A. Then I'm going to do 10 on E to the power of 3 times A. I'm storing my C as B. And then I'm just going to go alpha B times E to the power of alpha A times 13. N of 13 equals 46.4. And that was the last 2 marks you needed. So you guys can see, yes, it's a little bit trickier. I mean, you can say the algebra is harder, but you're not doing harder exponentials or anything like that. And that's how they can make it more difficult in a question 10 compared to if it was a question 5. All right. Any questions? No? let's go and do that. I think there's one more that I wanted to do. Oops, nothing here. Which is this one. Yeah, let's do it. All right, I'll just let you read it. Let me copy it and take it to another page. I'll let you read it for a little bit, and then we'll do it together. Maybe attempt what you think you can attempt. Okay. The intensity measured in watt per meter square of a sound is given by I, which equals 10 to the power of -12 times e to the power of 0.1 L, where L is the loudness of the sound in decibels. So, sounds very confusing. You know, might be a little bit trickier in terms of the wordings, but realistically should be very similar in math to the one we probably just did. So let's see how we go with this. All right. If the loudness of a sound at a concert is 110 decibels, find the intensity of the sound, give your answer in scientific notation. What an easy 1 mark for a question 10. All you had to do was sub in 110 for L. So I equals 10 to the power of -12 times e to the power of 0.1 times 110. By answer in scientific notation. So easy. Times e to the power of 0.1 times 110. That becomes 5.987 times 10 to the power of 1, 2, 3, 4, 5, 6, 7, 8. So -8. Anybody not get that? Okay, double line. Ear damage occurs if the intensity of a sound is greater than 8.1 times 10 to the power of -9. If that is greater than that, what is the maximum loudness of a sound so that no ear damage occurs? So it's just saying I is this. I might just do it down here. I is 8.1, so you just write 8.1 times 10 to the power of negative 9 equals 10 to the power of negative 12 times e to the power of 0.1 L. All right, I'm trying to solve for L. What's the first thing you would get rid of?
10 to the negative 12.
You divide that by 10 to the negative 12. Let's plug that into our calculator, get a simpler number to write, otherwise that's just annoying to write. 10 to the power of divided by 10 to the power of negative 12. Oh, beautiful. Thank God. 8100 equals e to the power of 0.1 L. Of course, what do? Log both sides. So we've got log 8100 equals 0.1 L divided by 0.1. And you guys are done. You got 2 marks. L equals, so maximum loudness is 89.99. 6 decibels. Come on, you have to agree for question 10. It's not hard. I've taught you well enough to be able to do this. AAA. By how much will the loudness of a sound wave have increased if its intensity has doubled? By how much will the loudness of a sound have increased if its intensity has doubled? So if that was 2i. So if it's 2 times this. Yuck. 2 times, as if they made you do that again. What a silly question. 2 times 8.1 times 10 to the power of negative 9 over 10 to the power of negative 2 equals e of 0.1 L times it by 2 because it's doubled. That should give you what? Exactly the same, but just times by 2. 8100 times by 2, 16,200. Then you would log both sides, and then you pretty much divide it by 0.1. So log answer divided by 0.1 is 96.928 decibels. But you didn't get a mark, because read it. By how much will the loudness of a sound have increased? So to get actually a second mark, loudness increased by 96.928 minus 89.996. So increased by 6.93 decibels. 6.93. That's it. I hope that makes you feel more confident in exam questions than the other way around. I mean, question 10 in 2011, so not so long ago. All right. Done. Done. That's pretty much all the basics there done. Now we look at differentiation and then hopefully move on to rates of change next week. All right. Derivative of exponentials. I'm sure there are a few of us that still remember this, especially from the other class. Anyone recall what I would say to differentiate e to the 4x plus 1?
Like the power stays the same, but you just differentiate the power and drop it down.
Yeah, that's it. All right. So for those who haven't learnt this, exponentials are always going to stay the same. So the good news is if that was y equals this, your y dash is always this. You don't bring the power down and subtract 1. It doesn't work like that. So they're always the same. You just have to differentiate the power. So what is the derivative of the power? It's 4, and you multiply it by that number. Aya, Andy, does that make sense to you? Because you guys probably would not have seen something like that before.
Yeah, it makes sense.
That
Yeah.
makes sense? So power, leave it the same. Everything, you just differentiate the power and then times it by it. So try this one. What's y dash for e to x? Well, it's automatically e to x. That's the good news. And then differentiate the 2x, which is 2, times it by the front. Minus, that's a normal differentiation. So how do we differentiate this one? Bring the 3 down. 3 times 4 is 12. Take away 1 from the power. That's that one. That's an exponential power of x. That's just a normal one. Does that make sense?
Yeah.
Let's do it. Yeah, let's do it again then. Y double dash. If imagine you had to, you don't, but just hypothetically say you had to differentiate again. What would it be, Andy? Differentiate. Yeah, say it. 4
4e to the power of 2x
minus.
minus 24 x to the power of 1.
Done. Good man. Easy stuff. Already got it. Find the derivative of this. I mean, the hardest thing is just going to be remembering each rule, like for an exponential compared to this. So the best thing is just to always revise back, go back over after 2 or 3 weeks and just look over and be like, oh yeah, that's what I do with these. Y dash stays the same. I can't make this any easier. Then differentiate 1 minus x squared. Voila. Find the derivative. Oh, interesting. Anyone want to give this one a shot? All to the power of 4. Then go ahead. 4.
So it's 4 bracket e2x minus 3. And then that's times by 2e. To the power of 2x.
Oh, very good now. And then there's something that's wrong.
The 3 on the, it's 3, yeah.
Oh, yeah.
Oh, yeah.
Thanks, Gregory.
Power of 3. And then, of course, 4 times 2 is 8. E2x. Anyone confused at how he got his answer? He used the chain rule, if you heard him say it before. So 4 e2x minus 3 power of 3 times derivative of the inside. You have to differentiate the inside. Okay. Let's go look at another one. Find the derivative of x cubed ex. All right. What do we do for this one? Let's try Rosemary. What do we do for this? Find the derivative of y equals x cubed ex. You got 2 x's that are multiplied.
Yeah.
What are you going to use? What rule?
Product rule.
Product rule. So u v y dash equals differentiate u, then differentiate v. All right. Y dash equals u dash. What's u dash?
3x squared.
Yep. Times v plus v dash. What's the derivative of an exponential?
Ex.
Yeah, it's still just ex in this case. Times u.
X cubed.
And then, I mean, it's good for you guys to get familiar with the fact that you can see there's an x squared that's common in both, and there's an ex that's common in both. So you can factorize that. Good job. Anybody have any questions for us for that one? Find the derivative of this. Again, product rule. U dash V plus V dash U. And then factorize 1 plus 5x. Find the derivative of e5x on x. Obviously, quotient rule. Greg, do you want to try it out? Y dash becomes
V dash U plus.
V dash U. Nah.
Oh
nah.
no, sorry. V U dash minus
U.
U
Yes.
V
Yep.
dash on
Yep.
V squared.
Yep.
Yeah, I always say it wrong.
I just say U first. It's just easier. All right, go.
So for the first, you differentiate the e, so that's just 5e x. So yeah, to our 5x, and then times by x, and then you do 1. Yeah, it's the same. Yeah, 5x, and then over x squared.
And then again, you can see e5x is common.
Yep.
So what's in your brackets?
You have 5x minus 1 over x squared.
Great work. Generally worth about 4 or 5 marks. Derivatives of exponentials in exams. Harder derivatives. Ooh, scary. Nah, it's not that much harder. It's the exact same. I can already see it. Don't worry. This one, e to the power of -1 on x. Yeah, maybe that one's a bit harder. Let's try that. So d of whatever on dx just means differentiate. That's another way of saying differentiate. So get used to that. Now the reason why we write it like that, let me show it to you, I guess. We write y equals e to the power of -1 on x. Then we can write from y, we can write y dash, or we can write dy on dx, correct? Now, if I didn't want to write y equals this and then say, hey, differentiate, what I could have said is y is this. So instead of this y, I could have just said, find me d of y on dx, where y is this. So the way you're meant to read it as is, okay, oh yeah, y is this, and you're asking me to find dy on dx. So when we write d of something on dx, it just means differentiate this. So differentiate an exponential. Well, the exponential is an exponential, so that just becomes e to the power of -1 on x times derivative of -1 of x. So -1 on x would become negative x to the power of -1. Differentiate that, you bring the 1 down. 1 down becomes 1. X, you take away 1. And then that just becomes 1 on x squared. I prefer you guys to write them as x squares than x power of -2. Long run, it will help you more. Okay. Not hard. This one, another product rule, not hard. It's just harder because obviously the root. So students would get it wrong because of the surd, not because of the fact that it's an exponential. Yeah, not hard. Ex squared. Yes, students will get this one wrong because they have no idea what's happening. Okay. Who wants to give this one a shot? Yeah, someone? No. Gotta pick again. Looks like Azra, it's your lucky day. Let's try this one again. Let's see how you go with this time around. Find f dash of x if f of x is this. I'll give you a clue, Azra.
Would
There's
you just add the powers because they're multiplied?
e to the power of
X squared
plus,
x plus 1.
yeah, that is exactly right. F dash of x equals
Be 2x plus 1
Yeah.
e to the power of x squared plus x plus 1.
See? He's like, oh yeah, they're just all the same basis, so just add the powers. So don't let it get too confusing, don't let it trick you. Good job. CWSA, so Catholic trial paper. That just means second derivative, power of 2, y double dash, y dash. Well, I don't need to do that just yet. I'm happy with that. I'm very, very, very happy with that. Okay. There it is. What we were doing a few weeks ago, tangents and normals. To find the equation of the tangent to the curve. Anyone remember the equation of a line?
Y minus y1.
Yep.
M brackets x minus x1.
And then of course, you're given only x equals 1. What do you need to do to find your other coordinate, your y value?
Sub into the original equation.
So y equals e to the power of 3 times 1, which is 3. Now, this is a decimal. We don't want to use decimals now because it's just going to make a big mess. So keep them in exact form, EQ. Yeah. And then, of course, how do we find m, Greg?
We differentiate the original equation.
So it becomes what?
X equals 1.
Sub in x equals 1, becomes your gradient 3e3, 3e3, and then your formula, your answer is, sorry, y minus y1 equals m x minus x1. Expand, bring everything to one side, and you should get this. Minus 3 plus 1 more is minus 2. That's how you're getting minus 2 E3s. You guys just try this now, yourself, just quickly. I'll give you about maybe 2 or 3 minutes. Okay. Find the equation of the tangent. So you've already got the point, which is not a problem. You just need to do y dash. Y dash is ex squared. Differentiate the x squared, which is 2x. To find your gradient of your tangent, you sub in your point of 1 into here. So that's 2e. And then y minus y1 equals mx minus x1. And then bring it all to one side. That's negative 2e plus e becomes negative e. Oh, negative. So tempting to write ex. Ex 2ex, not e to the x. Minus e. Any questions? Try example 17, that was from the 2005 HSC. Find the coordinates of the point P on this curve at which the tangent is parallel to this. That means you pretty much know what the gradient is. When you differentiate this, you'll know what the gradient actually equals to. Then you should be able to find the point P. Let's see. Anyone got it out yet?
Yeah.
Yeah. What'd you get?
0, 2.
0, 2?
Yeah.
Anybody not able or still working to get that out?
I'm still doing that.
Still doing it, but do you know what you're doing? So you like the gradient of this is 5, and then did you differentiate this?
Yeah.
And that becomes this. And then this gradient, the gradient of this is this because they're parallel. And then you start solving for x. Is that what you're trying to do? Or
Yeah, that's how I started with the differentiated part.
and then 2 divided by 2 will give you 1, which means x, eventually when you log it, it gives you 0. Sub it back into the original, and then you get e to the power 0 is 1, times 2 is 2, plus 3 and 0, so y does equal to 2. Make sure you're comfortable with that, and then move on. Yep. Aya, all good?
Mm-hmm.
Okay. Find the equation of the tangent to the curve x to the e to the x, and to 1 and e. Let's see if you guys are able to do this. Careful, this one's an exponential. This one is not an exponential, it's just a normal one. But you've got two x's that are multiplied. To do the tangent or to do the gradient, you have to use product rule. I'll leave you guys with maybe a minute or two again to think about this, and then we'll probably do it together. Okay, find the equation of the tangent. So like I said, this is u, this is v. Careful, u dash. You bring the e down. That's just a number. X to the power of e minus 1 times v plus v dash. Well, that's an exponential, so that becomes ex times u, which is xe. And then, of course, you just sub in 1. Did anyone actually get this line out? 1 to
Yeah.
the yeah, you got it. Okay. E times e is e squared plus e times 1 is e squared plus e. And then y minus y1 equals e squared plus e x minus 1. Expand e squared plus e times x minus e squared minus e, and then plus the e over, these two cancel out, and you're left with this. Again, for the curve, prove this, find any stationary points determine nature. Okay, no, that's application differentiation, so that's not just yet. Hold on. So stat points nature, that's more U12 level. Inverse. Yep, you should be able to do this.
Yeah.
Yes.
Can you send this booklet as well?
Yeah. Yeah, of course.
Thank
At
you.
the end of the lesson, we'll get this booklet. Okay. So, inverse functions. And then pretty much next week we are ready for rates of change now. So that's great. Inverse functions. Consider the function f of x equals e to the x, take away 1, take away x. Show that the minimum of f of x occurs at x equals 0. You can't. Okay, hold on. Can we do all of the rest? Yes. I'm just going to do the first one. I don't see why I can't just explain that to you guys. Oh yeah, points and reflections. Okay. We can't do inverses of this until year 12. So not yet in your yeah, done. I'm done. I think we're done with this book for today. So where are we? This one. And this one. I'll send it with the solutions actually. As you guys can have the solutions. Okay. Let's change. Or only 20 minutes. I don't want to. It's not. What I'll rather do is let's look at an exam paper. Okay. Let's just do every question. Really, we should be able to answer a lot of them except the probability ones. Question 1. Let me stop that recording. I really need all this in there.